Hello friends, welcome to UMRS Nasik. Today we are going to see CBSE class 10 mathematics chapter number 1, and this is our first lecture on this chapter, and in this lecture we are going to see Euclid's division lemma. So before to start with Euclid's division lemma, we need some basics. We know what is the long division method of integers. Suppose you are given a pair of integers, and suppose you are given two integers 17 and 6. How will you write 17, that is the larger number, by using the smaller integer? Of course, what you will do, you will divide the 17 by 6, and after dividing 17 by 6 you will get quotient 2 and remainder 5, so that number 17 can be written 6 into 2, that is 12, plus 5. So after dividing 17 by 6 you will get quotient 2 and remainder 5. So I can read this as 6 goes to 17 2 times, leaving remainder 5. Consider the second example. Suppose I am given a pair of integers 5 and 12. Now can I write the smaller number by using the larger number? Yes. So this 5 can be written, the smaller number 5 can be written by using the larger number 12 as 12 into 0 plus 5. So again, suppose I am given two integers 20 and 4. 20 is the larger number, so how can you write 20 by using 4? After dividing 20 by 4 I will get quotient 5 and remainder 0. So I can read this as 4 goes to 20 5 times, leaving remainder 0. So by seeing these three examples, we come across one result. And what is that result? For each pair of positive integers a and b, we have found whole numbers q and r, and in these three examples, what are the values of q? 2, 0, 5. And what are the values of r? That is remainder 5, 5, 0. So for any two positive integers a and b, we can find the whole numbers. These are the whole numbers satisfying the equation a is equal to bq. B means these numbers, okay, bq plus r. This is quotient and this is remainder, okay, this is the remainder, which is quite similar to division algorithm. We have seen in class 9 division algorithm as dividend is equal to divisor into quotient plus remainder. So here quotient and remainder can be a whole number, okay, can be a whole number. And if you observe, the value of a remainder is either 0 or greater than 0. The value of remainder is either 0 or greater than 0, but it is always less than b. Now what is b? B is the divisor, so these are the divisors. Okay, 6, 12 and 4. So we can observe that the quotient or the remainder r can also be a 0. Okay, now there is one puzzle given in your textbook, and that puzzle is: suppose a trader was moving along a road selling his eggs. An idiot who didn't have much work to do started to get the trader into a wordy duel. This grew into a fight, so he pulled the basket with eggs and dashed it on the floor. The eggs broke. The trader requested the panchayat to ask the idiot to pay for the broken eggs. The panchayat asked the trader how many eggs were broken. Okay, so one idiot man is there, one trader is there. The trader was selling the eggs. Since the idiot has no work, he started the trader to get into a wordy duel. Now this turned into a fight, and that idiot dash pulled the basket and thrown on the floor. Of course the eggs broke, and now the trader went to panchayat and asked the idiot to pay for the eggs. Now the panchayat asked the trader how many eggs were there. Now that trader responded like this: if counted in pairs, one will remain. If counted in threes, 2 eggs will remain. If counted in 4, 3 eggs will remain. If counted in 5, 4 eggs will remain. If counted in 6, 5 eggs will remain, and if counted in 7, nothing will remain. My basket cannot accommodate more than 150 eggs. So this is the puzzle. Now in that basket we certainly know that the eggs in the basket cannot be more than 150. So the eggs will be definitely less than 150 or less than 150. Now you will start thinking how many eggs will be there. So you will start, what you will do, you will count in pair and see whether one will remain or not. So we have eggs not more than 150. Suppose there are A eggs. We consider that there are A eggs. Then if I counted in pair, then 1 will remain. If A is equal to 2 times T plus 1. Okay, so how many pairs are here? Here are T pairs. Okay, after we are having T pairs, 1 remainder will be there. Similarly, if I counted in 3, I will get remainder 2. If I counted in 4, remainder is 3. If I counted in 5, remainder is 4. If I counted in 6, remainder is 5. If I counted in 7, remainder is 0. So which is the same thing that we have done earlier. means I have considered that there are ax, and I started counting in 7, counting in 6, counted in 5s, counted in 4s, counted in 3s, and counted in twice. What I observe here is that a was a positive integer and b is another positive integer, and if you see, these are the positive integers 7, 6, 5, 4, 3, 2, and if I divide this positive integer a by these positive integers, and what are the values of these positive integers of b, 2 to 7, I will get quotients p, q, r, s, t, and reminders 0, 5, 4, 3, 2. So which is the similar way what we have done earlier. And after writing this, I come across one result that the values of this reminder are either 0 or less than b. See, here reminder is 0, here reminder is 5, of course less than b, that is 6. Here reminder is 4, of course less than 5, that is your b. Okay, so what we have done, we have used here Euclid's division lemma. If I say we have used Euclid's division lemma, then you will ask how we have used this Euclid division lemma. Okay, so the answer to this puzzle is that if you apply a trial and error method, your answer will be 119. There were 119 eggs. If you start counted in 7, nothing will remain. If you counted in 6, 5 eggs will remain, and so on. Now Euclid's division lemma. Euclid's division lemma gives me one important property of the positive integers. And what is that property? See, given positive integers a and b, there exist unique integer q and r. Of course, q's quotient, r is remainder, satisfying the condition a is equal to pq plus r, where the value of remainder is always less than b, but it may be equal to 0 or greater than 0. The same result we have used earlier also, but there we were getting unique whole numbers, but now here we are getting unique integers. So this quotient q and remainder are the unique integers. Okay, so this is the Euclid's division lemma, and one of the application of Euclid's division lemma is that by using Euclid's division lemma, we can compute the highest common factor of two positive integers. Okay, so highest common factor is that number which is the highest divisor of both the numbers. Okay, suppose you are finding the HCF of a and b, highest common factor of two positive integer a and b. The HCF of a and b is suppose d, that means d is the highest common divisor which divides both a and b. Now we are going to find the HCF, highest common factor, by using Euclid's division lemma. and the question is find SCF of 455 and 42 by using Euclid's division lemma. Now we will start with the larger integer. Of course, among these two, 455 is the larger integer. So now if you divide that larger integer by 52, okay, what you will get? You will get dividend 455 is equal to quotient, that is our 42, into divisor, that is our 42, into quotient 10 plus a remainder 35. Means we have used the Euclid division lemma to these two integers 455 and 42. Similarly here a remainder is 35. So since remainder is not 0, continue to use again Euclid's division lemma to 42 and 35. So using Euclid's division lemma to 35 and 42. So after dividing 42 by 35, we will get quotient 1 and remainder 7. So again here remainder is not equal to 0. That means again we have to use Euclid's division lemma, but now we are going to use Euclid's division lemma for 35, that is b, and remainder 7. So 35 is the larger integer among 35 and 7, so 35 can be written as 7 into 5 plus remainder 0. So after dividing 35 by 7, we will get quotient 5 and remainder 0. So now stop here. When remainder becomes zeros, then stop there, and in this step, what is the value of divisor? The value of divisor is 7. Okay, so the value of divisor is 7, and this value will be now HCF. Okay, your required HCF. So we are using these steps. So these steps are also called as Euclid's division algorithm. Algorithm means what? Algorithm means step by step process. Okay, so hopefully you are getting this, how to use Euclid's division lemma for two given positive integers to find HCF. Okay, now thank you for watching this. Please do subscribe our EMRS Nasik channel. Thank you.